Okay, we're now going to look at a two-sample t-interval example. And so here we're going to, the two groups of comparison are a group of students who take a test in person, which is called proctored, right, when someone is in the classroom watching them take the test, versus a group of students who does it online. And we're trying to estimate the difference between the mean scores of those two groups. Right, the difference between the mean scores of those two groups there. And so we have the summary data to give us a clue already, to give us a sense of what the outcome is. But again, these are samples, and so what we're trying to estimate, is there a difference in the population, right, in the two groups of all students who take in person versus online, and that's why we're using this here. And it looks like from the evidence that maybe online score higher, but statistically, right, comparing their variances, their standard deviations, can we say that we're confident that this is true for the population? And again, if the data is not here, we'll go ahead and use an alpha of 0.05, which is a 95% confidence interval. That's what we'll go ahead and have. Again, we're trying to calculate the mean differences between the difference between the mean scores. Okay, and so keep in mind as we're doing the subtraction, one group minus the other. If in-person scores are higher, right, for group 1, then the difference is positive. If the in-person scores are lower, then the difference is negative. And so there's some mathematical meaning between those values, right, when you subtract and find the difference between the two values. So right now we're going to do group 1 minus group 2 to see if there is a difference between them. And so we go ahead and check the conditions: independent, right, so less than 5% of the population. We're good there. Random, it doesn't give us if the two samples were taken independently, but it doesn't say how we were random. But so again, in the sense of we're always got to be careful of our data, if the or of our interpretation if it's not random. We'll go ahead and still do the calculations, and they're large enough, meaning they're greater than or equal to 30, right? And so we're good there. And so now let's go ahead and calculate the difference. And we're going to do that either on StatCrunch or ArtaStat. We're not going to use those complicated formulas we showed you. We're going to go ahead, and so for StatCrunch, we're going to go ahead and let's go ahead and do that. Stat, in this case, it's T calculator to sample, and we have the summary statistics. And so we're going to go ahead and enter in that data there for sample 1. So that would be group 1 is going to be our proctored. So the sample mean for that was 70.29. The standard deviation, the sample is 22.09. So a lot of variance it looks like in the score. Sample size was 30. And in this case here, we have the sample mean for group 2, which was online, 74.26, standard deviation 18.15, and then your N is 32. Thank you. And so we'll leave it that way. And then we're going to do everything else stays the same. You're going to go ahead and click confidence interval here, and then we compute. And then you go ahead and you'll see you'll get that answer right there, -14 to -14.29 to 0.635. You have those numbers right there. And so now let's go ahead, and so that's your confidence interval, 95%. Let's go ahead and then look at here, compare two means. This is the ArtaStat. As that comes in, you're going to go ahead and remember we're doing a two-sample means population. We have summary statistics. There's your groups, group 1 and group 2. So your sample size, you got to go ahead and put in the sample size for group 1 is 30. We're looking at 70.29 again. Standard deviation was 22.909, There you go. For the other group, 32, 74.26, and then the standard deviation. And so again, very similar to what we were doing in StatCrunch. And you go ahead and then you'll see the difference between these two. You'll get the confidence interval right here, lower bound and upper bound. And then you can see kind of the span. Remember, we're trying to estimate the difference between the populations. We just had 2 samples there. And so we're going to go ahead and use those numbers. Let's get back to our notes here. And so in here, we now know the confidence interval. The values are from 6.35 and negative 14.29. And so now we know we're 95% confident that the interval 6.35 to negative 14, oh, those are backwards, sorry, from negative 14.29 to 6.35, sorry about that, right, that interval from those 2 values there, from negative 14.29 to 6.35, right, captures the true difference between the scores of the groups. What that means is that it's still possible with these scores that we can't tell the difference, right? Since the constant confidence interval contains 0, we say there is no difference in scores between the 2 groups, right? It's possible for group 1 to be bigger. It's also possible for it to be smaller, and so we can't make any conclusions about there is a difference between those.